Today we're going to be talking about z-scores, and our objective is that we will be able to calculate z-scores and use z-scores to compare two sets of data. So this is a picture of the normal curve. It's used in a lot of statistical analysis. The two things we're going to talk about on here are the mean, which this is a lowercase mu. It stands for the mean. It's the symbol we're going to use, kind of like if an M and a U had a baby. And then the other symbol we're going to use is a lowercase sigma, and that stands for standard deviation, which we'll talk about in a minute. So on our normal curve, the mean is always in the middle, and then each line is worth one standard deviation. So this is the mean plus one standard deviation, plus two standard deviations, plus three standard deviations. Or minus one standard deviation, minus two standard deviations, or minus three standard deviations. All right, so what is standard deviation? It is a standardized measurement, and it helps us learn about the spread of the data. So if the standard deviation is a big number, the data is really spread out. If the standard deviation is a small number, the data is close together. So a data set's standard deviation, which we said is the symbol sigma, can be calculated using our calculator. And you guys have done this before. It's in that same list as the mean and the stuff for the box and whisker. It's all the same. So we're going to go to Stat, Edit, clear out whatever in there, and I'm going to put in 4, 9, 11, 12, 17, 5, 8, 12, and 14. Stat calc 1, and go to calculate. And we're going to write down two pieces of information. The x with the line over it, remember this is the mean, even though we're going to use mu. So 10.22. And the standard deviation is right here, 3.94. So a z-score is the number of standard deviations from the mean. So if it's positive, it's above the mean. If it's negative, it's below the mean. So if a data point is 2.5 standard deviations above the mean, what is the z-score? Well, it would be 2.5. If a data point is 1.5 standard deviations below the mean, since it's below, it'll be negative, but the z-score would be negative 1.5. So what would that value be for the data that we just had? Since we're going above or below the mean, we're going to start with the mean. Above, we'll add. We're going up 2.5, and then we'll multiply that with the standard deviation, so 3.94. And when we put that in our calculator, we get that it is 20.07. So same idea here, 10.22. Since we're going below, we would subtract 1.5 times the standard deviation. Again, type it in our calculator, and we get 4.31. So here they basically told us what the what the z-score was. If we need to calculate the z-score ourselves, the z-score formula is x minus mu over sigma. Remember, mu stands for the mean, sigma stands for the standard deviation, and x is the data point they give us. What we can use z-scores for is if something's statistically unusual, if we're not expecting something to happen. This is if the z-score is more than plus or minus 2 from the mean. So if it's more than 2 standard deviations, either above or below the mean, it's statistically unusual. So Kelly's test score on the quadratics test was 95. If the class average was 78 and has a standard deviation of 5, determine if Kelly's score was unusual using the z-score formula. So we're going to calculate what z is. And remember, it's x minus mu over standard deviation. So mu, the mean. Mean and average mean the same thing. So my mu is 78. Standard deviation is 5. And my x is going to be whatever they told us about the person or the object in the problem, which was Kelly got a 95. Now we're just going to put this in our calculator, but I'm going to warn you to be careful. If you type like this, 95 minus 78 divided by 5, you will get a very, very, very wrong answer. Our z-score should not be bigger than 5 or 6 at a huge maximum. You need to make sure that you're using alpha y equals, enter, 95 minus 78 over 5. And then we're going to switch it to a decimal, so math 2, enter, and get 3.4. Your other option is do parentheses 95 minus 78 divided by 5. That also gives us 3.4. So this is correct. Don't do that. All right, so we got that her z-score is 3.4. Is this statistically unusual? Yes, it's unusual because 3.4 is greater than 2. It's more than 2, so it's unusual. It's rare that it happened. The other reason we use z-scores is to compare two sets of data. So before we can compare them, we have to convert them to z-scores. So suppose your friend earns an 80% in AP World History and a 90% in Art 1. The average score in AP World History is a 72 with a standard deviation of 6.5. The average score in Art 1 was an 88% with a standard deviation of 3. Statistically, which grade is better? So I'm going to highlight all my information about AP World in one color. So AP World, that's my friend's grade, the average, and the standard deviation. And then I'm going to go back and highlight art in a different color. So since there's two classes, I'm going to do two different z-scores. So for AP World, I'm going to take my friend's score minus the class average over the standard deviation. And then for art, same idea. My friend's score minus the class average over the standard deviation. Then I'm going to put these in my calculator. So 80 minus 72 divided by 6.5 gives me a z-score of 1.23. And 90 minus 88 divided by 3 gives me a z-score of 0.67. So, statistically, AP World is better because the z-score is farther from the mean. It's a bigger number. All right, you have a normal distribution, which is just saying we can use our formula, with a mean of 235.7 and a standard deviation of 41.58. Which data point has a z-score of negative 3.45? All this is a different way of asking this same question. Take the mean. Since the z-score is negative, we're going to subtract 3.45. And since z-scores are the number of standard deviations, we multiply it with the standard deviation. Type that in your calculator, you get 92.249. That's all for today. Fill in your summary, and I'll see you in class.